And then the window is like, say, here. Hits the window. So something like that. How high up is the window? And how fast do you throw the rock? All right. Everybody see this okay? All right, here we go. This is not much different than the other questions so far, but it is a motion question, so I'm going to start off with delta. I guess I could put delta x. Does it bother you if it's delta x, even though it's going up? Does that matter to you guys? Because next week we're going to do two-dimensional motion, and I'm going to change anything that's up and down to y, and so I don't want you to be confused, but it's just a placeholder anyway, so who really cares? So I'll put x. Then I'm going to have initial velocity and final velocity and acceleration and time. And we're told that we throw the rock upwards at 45 meters per second. And that there's, it's got to travel at least 12 meters upwards. That's all the given information. So we have vectors here, so let's go ahead and not forget to decide positive and negative. So what do you want? It's your problem. Do you want up to be positive or up to be negative? All righty. Up is positive, which tells me that it's positive 12 meters, positive 45 meters per second. That's only two pieces of information. I need something else.
Acceleration of gravity.
Yep. This object is being accelerated by gravity, 10 meters per second squared, and it's being accelerated downwards, so that's negative. We want when it hits the window and how fast it's going when it hits the window. So it doesn't matter which one of these we solve for first. So let's do, I'm going to help you guys out a little bit. I want to set up both parts, but not decide what to solve yet. So let's set up the time first. If I'm solving for the time's going to be, let's see, delta x equals 1/2 a t squared plus vi times t. That's the given information. If I plug all that given information in, I'm going to get 12 equals 1/2 times negative 10 t squared plus 45 t. Right? It's a quadratic. It's a pain. And I'm going to have to use the rules of quadratics to solve it. And I'm not even sure this one factors. We'll see. The other one, though, is vf squared minus vi squared equals 2a delta x, which for this one will be vf squared minus 45 squared equals 2 times negative 10 times 12. Hello. Goodbye. Right? Now, the reason I want to point out that this is how you get to your solution is, but by the way, this is all the physics there is. There's a little more physics in a minute, but this is it. When you get your velocity, at the very end, you're going to get VF equals plus or minus some number. And when you get your time, you're going to get two different times. And just so you know, both of them are going to be positive. In this problem, they'll both be positive. I'm bringing it all up because solving a quadratic for some of you is a deal breaker. You can't do the quadratic formula right. It scares you. I don't care what it is. You just don't like it. You don't have to do the quadratic formula. You can solve for the velocity first. If you solve for the velocity first, you can use something much easier to do this problem. Right? Much easier. However, in both cases, you are saddled with figuring out which of these times is the right one or which velocity to choose. If you make the wrong choice, you get the time wrong. You make the wrong velocity choice, you get the time wrong again. So you have to figure out which one do you want. And you have to understand that there's two times because it passes the window once on the way up and then on the way down. That's why there's two times. That's why they're both positive. You want the longer time. because it says it strikes the window on the way down. Or, what direction is it going when it strikes the window, upwards or downwards? If you understand that, you'll understand that when it reaches the window, it has a negative velocity. Choose the negative velocity. And this should also, I have a few kids who are pretty insightful. This should tell you something important. That at this height here, let me see if I can do this. At this height of the window, right here, the rock has the same velocity going upwards as it does going downwards. That's why it's plus or minus in that equation. That equation just asks you how fast it's going when it's 12 meters above the ground. It doesn't know whether it's on the way up or it's on the way down. That's why it has plus or minus in it, because both answers are actually correct for what you asked. You have to interpret that you want the downward one, but they both are correct. So this problem is a little bit different. It's got some stuff in it. Don't be scared away from it, but if you want, we'll go ahead and get the final answer here. Who wants to get the final answer? Who needs the numbers? All right. So final answer. Let's do 0 equals negative 5t squared plus 45t minus 12. What do you think? Do you think that factors? I don't know if it does or not. I don't think it factors. Do you? I can't. I'm just trying to think of pairs. 2 and 6. What's that? Will 3 and 4 do it? I don't think 3 and 4 will do it. 3 times 5 is 15 plus 4 is 19. I don't think it factors. I think we're gonna have to use the quadratic formula. Sorry. So this will be fun. Quadratic formula, my favorite. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Good luck. You guys break out the fancy calculators. You got all that fancy hardware there. When do you do it? I'm not going to do it. I might be able to, but I'd rather you do it. Even if you can throw a 100-mile-an-hour fastball, you probably can't throw that fastball straight upwards. So I think poor choices here. So Mr. Shelton coming up with numbers for the test probably should have said 25 meters per second. 45 might be a little gregarious, a little reaching. Well, maybe you wanted to finally show Juliet a lesson. You know, listen, I'm tired of playing this game. Your family sucks. Let's just handle it, all right? So we're going to take the second one anyways. That's the right answer. I want you to know that's when you should turn in 8.72. And then to find the velocity, this one's. I still don't know 45 squared. It's a lot. 2,000 what?
2025.
Okay. I'm not going to memorize that. Minus 240? Yeah, 240. And then take the square root. Then put plus or minus. I don't know what it is, don't care. It's slightly less than 45. So, did you find it yet? Like I said, slightly less than 45. I'm going to go with 41. That's my guess. 32? 42. That was close. Which one's right? The negative one. It's going down. In fact, I'd rather you not write negative. I'd rather say 42 meters per second downward. That's what I'd rather you say. There you go. All right, and I need something. So how about it starts by going forwards and then backwards? Is that okay? So would that be a line in the positive side going towards the negative, or a line in the negative side going towards the positive? It matters.
Whoa. Positive going towards negative.
So if it's going to go away from me and come back, it should be positive side and negative side. That would be going forwards and then back. If it was negative side, then positive side, it went backwards and then forwards. Right? We assume forwards and backwards. Then this is a graph of an object with a positive velocity first and then a negative velocity. This is a graph of an object that has a negative velocity first and then a positive velocity. So this one went backwards and then forwards. The other one went forwards and then backwards. You guys follow okay?
What do you mean by forward and backwards? Like,
Well, this side of the velocity, this side is all negative. So all of these velocities all along this part of the graph is negative. So if I assume positive in front of me, this whole time, the first half of this, it's going that way. It's negative velocity. And then at this point, it turns around. And then this side, this whole part of the graph, it's all traveling positive. So it went that way, turned around, then started coming back. So it's like there's a ramp behind me, and I threw the ball behind me. I don't know how else to say it. Does that work okay? So let's do this. We'll do this one. I'm going to shift it like that. And I'm going to put some numbers to it. And I'll do my best here to be quick. Oops. There we go. So we have some stuff here now we can use. So the first thing I would ask you guys is make a model of this object's motion. Make an equation that models this object's velocity. Make an equation that models this object's velocity. What I said in the practice test was a model equation. You know, it's like, this is a straight line, y equals mx plus b. Make an equation that models this object's velocity. Look, you did this before. Don't give me that look. You know what y-intercept are, you know what slope is, you know it's graphed on the y-axis, you know graph on the x-axis. You can do this. I promise. All right, velocity is plotted on the y-axis. Time is plotted on the x-axis. So the first thing I'll do is recognize that I'm going to change my y and my x into v and t. This is a plot of an object's velocity versus time. I can interpret the slope here. It means the acceleration. So I look at this graph and I notice that it rises 6 in 3 seconds. So its slope is 2. The y-intercept is -6. This is an equation that models this object's motion. If you don't like that explanation, I'd say as motion equations go, v final equals at plus v initial. This too is a model of the object's motion. The acceleration and the initial velocity are clearly marked on the graph. So I can have vf equals 2t minus 6. I'd still get the same thing. That's what I mean by a model of the object's motion. Now that being said, what time does the object make it to 10 meters per second? I want to know what this time is right here, because that's when the object's at 10 meters per second. So to answer that question, I plug in 10 meters per second for v and find out what t will tell me that. And I'm pretty sure we're looking at 8 seconds. So now I would say, what is the distance traveled by the object in the first 8 seconds of its motion? Now that one's a hard question because you can't use your motion equations for it. The distance traveled by the object will be the sum of this area and this area. And I have to compute them separately. I can't compute the displacement over the whole interval because the object changes direction. This is not obvious. This would be a question that's challenging. There will be challenging questions on the test. But I'm not asking too much. 1/2 times 3 times -6 tells me that it moved -9 meters in the first 3 seconds. Over here, 1/2 times 5 times 10 means it moved 25 meters in the last 5 seconds. If I want to know the distance traveled, I only add the number parts here. It traveled a total of 34 meters. It went 9 meters backwards and then 25 meters forwards. It traveled a total of 34 meters. That's the distance. We have talked about this, but it has been 2 weeks. Are there questions about this? If this represents one question on the test, you're gonna get this one wrong. There'll be other questions to get right. You'll still get an A. But there's not gonna be a guarantee that you'll be able to answer every question. I am gonna have hard questions on the test. I don't believe this is particularly hard if you know what to do. If you don't, it's impossible. Yeah?
So if it was asking for the displacement, then you leave the 9 negative?
Yeah, displacement, you'd either leave the 9 negative, or you can say displacement is 1/2 initial velocity plus, you could pick one of your motion equations and do it that way too.
What is the,
This would be, let me just finish, -6 plus 10 times 8. So, 4 times -60. Oh, I'm sorry, not 4 times -60. It's 4 times 8 is 32, half of 32, or, yeah, half of 32 is 16. So you can do it that way, or you can just add those two numbers, leave the negative sign in there and get 16.
so if we want distance, we can't,
Let's draw. There's that. That. All right, so this is 10 seconds, -12 meters per second, 8 meters per second. This is velocity. And this is time. All right. You guys see that okay? All right, you have to write a mathematical model. There's probably 2 ways to approach this. I'm going to approach it from the standpoint that this is a straight line and that we know that the equation for a straight line is this. If you would prefer, though, you could look at it from the standpoint of, I have a motion equation, that too is a straight line. Maybe I can make that work. But I'm just going to use the equation of a straight line because these are the same thing. The y-axis has the velocity. The velocity at some point or any point in time. And that equals something times t because the x-axis is time. Looking at this picture, the slope, it goes from 8 to -12 in 10 seconds. That's a change of velocity of -20 in a time of 10 seconds. So that's -2 meters per second squared. So -2. And it has a y-intercept of 8. That is a mathematical model. So I would expect the next question to say, how fast is it going at 20 seconds? Right? You would not use the graph, you put 20 in for t, and you'd be able to figure out how fast you're going. Okay? Now, I also feel you should be able to tell me how far the object traveled and where is it compared to its starting position after it traveled 10 seconds. Those are two different questions. One is asking you to tell me the distance traveled by the object, and the other one is the displacement. And we've talked about this, but I've not really emphasized it a lot. If this is on a test tomorrow, it's purposely designed to be one of the more difficult questions to see if you can discriminate between distance and displacement. You can choose to get this one wrong, or you can, remember that there is a difference between displacement and distance. Distance is how far the object has traveled. If I want to know how far it traveled, I probably need to separate out the times it was traveling forward from the times it was traveling backwards, because displacement doesn't take that into account. So if I merely find the displacement, that won't be how far it went. So to find the distance, I'm going to separate out the two areas and find the area here as 1/2. Ooh, I need to know when this is. You guys have the graph. When is that? I mean, I could probably figure it out, but I don't want to. When is the velocity 0? 4 seconds?
Yes.
So 1/2, 4 times 8. So 16 meters forwards. Down here, 1/2, 6 times -12. So that's going to be -36 meters. So if I want to know how far it went 52 meters. 16 of them forward and 36 of them backwards. If I want to know how far away it is from where we started, then it had a displacement of -20 meters. It is -20 meters away from where it started. Does that make sense?
Yes.
So I know this is very likely to be on a test tomorrow. It's, to me, a graphing exercise, and that's a part of the exercise. Okay. Any questions or follow-up? All right, so we want to know, how long it takes to hit the window and how fast it's going when it strikes the window, the only two pieces that are left. So we'll do it. They gave us several pieces of information. So let's kind of figure out what they gave us. First, do you want up to be positive or up to be negative? Okay, whatever you say. So delta x is going to be positive 12 meters. Initial velocity is going to be positive 45 meters per second. And that's all they gave us. So we can't do it unless we know something else. Do we know anything else? I think we do. Yes, sir.
Is the acceleration
What do you think it is?
10
And why do you think that?
because of the free falling gravity?
Yeah, that's a good call. Let's go with -10 now. Because you said up was positive, so I'm going to make downwards negative. All right, I got 3 pieces of information. I need to figure out both the final velocity and the time. Who's afraid of having to use the quadratic formula on the test? You should be honest. Yeah, I would be too. Last class period, when I had students have to use quadratic formula, there were a lot of variety of the answers, considering that they all had the same numbers and the same formula. And I wrote the formula down. Look, it's not that you guys are incapable. It's that you guys often make mistakes typing things into your calculator. You forget to put the squared, or you forget about the plus or the minus. You make weird mistakes. Please understand something. There is no prize for writing down very little on your test. So grab the back of the piece of paper. Get a piece of scratch paper. If you have to write down every step, write down every step. I mean, look, Do you think, who am I going to think less of? The person who wrote down every step and got the right answer? Or the person who went right from the quadratic formula to the wrong two answers? Do you follow where I'm going? I know it's just the arithmetic. But if you know how to do it, don't be scared of it. There is a way around it. If you don't want to do the quadratic formula, then find the velocity first. If you find the velocity first, you don't have to use the quadratic formula. So let's do it that way for those of you who have trouble with it. I'll find the velocity first by recognizing I have 4 pieces of information, which leads to VF squared minus VI squared equals 2A delta X. Good so far? No, good. So VF squared minus 45 squared equals 2 times negative 10 times 12. Okay. 2 times negative 10 times 12 is easy. That's negative 240. 45 squared, though, I don't have that sucker memorized. It's like 2,000 and 2025, perhaps. They just did it 2 class periods ago. If you're not going to do it, I'm not going to do it either, though. I'm not doing it the long way. If you expect me to do the whole thing, that's just mean of you. 2025. Oh, wait. So 2025 minus 240, take the square root. Fantastic. So VF is plus or minus, I still don't know the answer. Not really caring about the answer. I think it's 42. So I'm going to go with 42 meters per second. Which is it? Is it plus or is it minus? You choose wrong, you're going to get the next answer wrong if you don't use the quadratic formula. How do you know it's minus? It's going down. Yeah, we said it hits the window on its way down. You chose downward to be negative, you better choose minus. So, I actually have an eraser. I'll just erase there. So, minus is the right answer because it's going downward. Now look, if we want, we can go ahead and figure out how long it's in the air. I'm going to choose the easiest relationship for that. That's going to be VF equals AT plus VI. There's no easier one than that. That's going to be negative 42 equals negative 10T plus 45. And that looks to be like negative 87 equals negative 10T, or T equals 8.7 seconds. Now look, if you chose wrong there, you would have put positive 42, and you would have got a third of a second. And by the way, those are the 2 times you get when you use the quadratic formula. A third of a second and 8.7 seconds. So you're going to get the same answers. Interestingly enough, I dare anybody to throw something in the air and have it stay in there for 8 seconds. I don't think any of you can do it. 8 seconds is a long, in fact, I don't think you guys can make a paper airplane that could stay in the air for 8 seconds, let alone throw something upwards and have it stay for 8 seconds. That's a long time to stay in the air. If you don't believe me, 45 meters per second is like 100 miles an hour. So unless you can throw a 100-mile-an-hour fastball straight up, like pitchers couldn't do it because they're not throwing straight up. Their hand has to stop halfway through the motion if they want to throw straight up. 100 miles an hour straight up. So I don't know that I really chose an appropriate velocity for this question. Perhaps I was in a hurry. Perhaps I wasn't thinking it all the way through. Perhaps I wanted to make sure it made it all the way to the window. If I choose a velocity too small, it doesn't make it to the window if I'm not careful. I write new questions all the time. Maybe it was getting late when I wrote this one. I don't know. 8.7 seconds. That's a long time to be in the air. Good question, though. Lift and big old 35-inch tires, so it doesn't drag race at all. In fact, I've seen people pedal past me. So this is not me, and I don't want you to take away the idea that that's what I do. But let's just say, for argument's sake, that Mr. Shelton decided to drag race his Jeep. That's what my Jeep looks like. There, my Jeep. All right, so I'm going to drag race my Jeep. You guys can't see that, can you? Could you shut off the first switch next to the red one? I like my Jeep, though. It's recently brought me a little bit of displeasure because I've had trouble with the suspension system, but I'll take care of it. It's got like 110,000. You know what's great about driving a Jeep like this is I can park it anywhere I want. So I always find the nicest car in the parking lot and park it next to that. It's all banged up. It's got chips in the paint. You know, it's the perfect car for school. You know, if I ever tick one of you guys off, gotta go, smash the crap out of it. You know, get it out of your system. I'll get the video later, but you know, it's great. If there's no place to park, I just make a parking spot wherever I want. I love it. I like when people cut me off too. I'm like, you know, this thing doesn't stop, right? I can stand on those brakes, but it's not going to stop anytime soon. So it just cracks me. And I'm like, well, you can hit. Go ahead, hit me, run into me. I have people tailgate me all the time. I have, my hitch is like lowered 4 inches so I can get my trailer for my kayaks, and I'm like, I am going to basically put my hitch right through your engine. So run right into the back of me. There might be a scratch on my bumper, and I won't even notice that it's there. Now, if you rip any of my marathon stickers, I'll be pissed. But aside from that, I love driving my Jeep. It's like the perfect just get away from me kind of vehicle. So I got a new top on it though that doesn't seal great. So like right now with all this rain, yeah, it drips right on the driver's seat though. And if I forget to fold the seat forward, it'll be a puddle. And I'm pretty confident I didn't fold the seat forward. And I have to go to the doctor's next period. I'm gonna go in there, I'm gonna look like I wet myself. So I'm very excited about the prospect of going to the doctor now. So I'm recording all of this. So if you listen later, you get all of this. All right, 2 minutes. All right. To all my Ugandan listeners, we're with you in spirit. All right, so the Jeep starts from rest and accelerates to 35 meters per second in 6 seconds. No, it doesn't. No, it doesn't. I'm not sure it'll go 35 meters per second, but 35 meters per second is just a little over 70 miles an hour. And although I have gotten my Jeep that fast, it's unpleasant at that speed. Unpleasant. But it does so. It's definitely not going to do so in 6 seconds. So let's take a look at all the possible things that could be asked here, and there's only 2. So I have those motion variables, and I'm going to choose, not that this matters that much in this question, but I'm going to choose that way to be positive. Does that make sense? The direction the Jeep's going, and we'll make this way negative. So I'm not exactly sure what the problem asked, but I do know that my initial velocity is not given, but it's implied that I didn't start moving until the light turned green. I do make a full and complete stop at every stoplight. Did you hear that, all police officers in the Tampa Bay area? I make a full and complete stop at every stoplight. I got pulled over the other day, and I hate being pulled over. I got pulled over the other day because I rolled through a stop sign. Now, the truth is I didn't. I stopped fully. The car in front of me rolled through the stop sign, and I just kept going with them. But I was stopped before that. So what I did was wrong, and the police officer explained it to me very politely. Noticing that I was old and driving either my hot young girlfriend or my 19-year-old daughter back home from the gym, he was kind enough not to give me a ticket. And yes, it was my daughter, but I'm not sure that was the takeaway the police officer had after he pulled me over. Both sweaty and stinky from the gym. Oh, this takes place in 6 seconds. There we go. All right, so, and I'm just trying to spice this up because you said it was boring. That's the only reason. And because I've been doing this all freaking day. Do you know how tired I am of saying, these are our 5 variables. You can put 3 of them here. Now you must figure out the 4th variable. Okay. How about this one? This sounds fan-freaking-tastic. I wonder if there's an equation that will make this happen. I'm sure as heck there is. Don't listen to this videos at home, kids. All right, so I'm thinking that's going to give me the acceleration. I don't know if they want the acceleration, but that would do it. And so, they do? Fantastic. Then I'm glad we're paying attention. It's so funny how people have brought me their equation cards, and both of these equations are on it, and they think that those are two separate things. But they are not. They are the same. I just solved one for A, and the other one solved for final velocity, but still, this is still going to be 35 over 6, which gives me an acceleration of, I don't know, a little under 6, a little more than 5. How about 5.8? Maybe 5.9? I don't have a calculator. And I'd be happy to leave it 35/6, but you guys won't. You'll tear it apart with a decimal.
5.8.
5.8. And that will be in meters per second squared. I don't really care too much. Somebody asked me how many decimal places. I'll say you should frame your answer in an appropriate number of significant places, which based on the way these numbers were given would actually be 6 meters per second squared, because the smallest number of significant places was the 6 seconds. But I am not a strict adherent to significant figures. But if you give me the entire register of your calculator, I'm taking a point off for you being obnoxious. And I'm okay with that. So, strictly speaking, you should answer your questions in the appropriate number of significant figures based on your problem. That's the technical answer. I know the guy writing the AP test will probably be a significant figures Nazi, so you should probably anticipate that. Yes, sir.
Would you get your answer wrong if the units are incorrect?
Yes, you'll get a point off if you do not have the right units. I should take 2 points off if they're incorrect units. But I'll probably give you the same point off if they're just incorrect units. But you should expect that every one of these problems has a built-in point for every unit. And since this question asks for units for 2 different answers, you sure as heck better realize then that I'm looking for both. Let's see, this one is displacement, and I have time, so I'm looking for VF plus VI times T. This question was given on a test where the motion problems had just been introduced. So these problems were almost always based on having the time, the initial and the final velocity, because that's what's on the graph. Don't expect that on your test. I'll give you whatever I feel like it. So half of 6 is 3. 3 times 35 is 105 meters. There we go. All right. Because there's a guy in the history department that looks like a vampire. You guys know what I'm talking about, right? Yeah, he does. All right, what is number 2? Why don't you go ahead and read it for me, because I don't remember. Sorry, I just said Winehurst out loud. He's a nice guy, though. It's way soon, so if sharks can fly out of the clouds, then why not dogs? Maybe Dognado will be next year. What?
What's the circle under the arrow?
Well, it was a raindrop, but then I decided to draw a little ARF instead, so I got a woofer in there.
So then the dog is next to it?
Sure, why not? Maybe it might be a little crap, because the dog would probably be scared if it was flying through the clouds. I think mine would probably crap itself. Anybody have a dog that would crap itself? All those Chihuahuas would, like right then. I'd be careful about them raindrops, because it probably wouldn't be water. All right, so is up positive or is up negative? You choose, Rachel. You make that decision. I believe in you. Really? Again? You want what? Up to be positive? I didn't hear what you said. Okay. Sure, I don't care. I'm not scared of this decision. You seem to be. So you're going up positive. All right, done. The dog falls 900 meters, has an initial downwards velocity of 25 meters per second, and the acceleration of gravity is 10 meters per second squared. I know it's really easy for me to throw these out there because I've done this kind of a bunch, but understand there's no real surprise. If it's got meters, it's going to be a displacement, unless they're trying to trick you. So make sure you read your problem thoroughly. The acceleration is going to be gravity. It's falling from the clouds. Now, we have decided to make upwards positive. All 3 of these measurements are actually negative, right? Downwards. And we want to find out how fast the woofer's going when he hits the ground. So I'm looking for a relationship that has everything but time in it. That will be VF squared minus VI squared equals 2A delta X. So it's kind of funny because this relationship can't tell me whether the dog is going up or down when it hits the ground. But I can't put all these things in here. That negative 25 is just going to be squared anyways. And negative 10 times negative 900 is just going to cancel out the negatives there too. Kind of weird the way that works. The right side's going to be, looks to be 18,000. And the left side, let's see, 25 squared is 625. And then I'm going to add it to both sides. So let's just cut to the chase here and get that VF squared is going to be 18,625. Now this has to be a positive number because you can't take the root of a negative number. So if you make a mistake and don't catch it, be careful. If you end up having to take the square root of a negative number, it is likely you chose one of your signs incorrectly. And that's a good indicator that, no, you're not making necessarily a mistake in what you're doing. You made an initial assumption wrong. Just go back and check your positives and negatives. Don't brute force through it, which is what a lot of people do. They just take the square root anyways. Don't do it that way. That is a indicative that you've made a mistake, and you should find it. So I know you guys would love for me to be able to tell you what the square root of 18,625 is, but I don't know it. I do know that I'm going to put plus or minus in front of it. So can somebody tell me what that's going to be?
136.
Yay, 136. So 136 meters per second, or about 270 miles an hour, 280 miles an hour. I don't want to get hit by this. I mean, we're going really fast. And it would be negative to indicate downward. So don't drop your dog from the clouds. You know, people have survived falling, without a parachute before, but it's unlikely. You wouldn't be traveling that speed. You would reach terminal velocity. The problem can say one of three things. It could say, what is the speed of the dog as he reaches the ground? That's easy. That's 136. It could ask, what is the magnitude of the dog's velocity when it reaches the ground? That's easy too. That's 136. Magnitude doesn't include direction. It's just the number part. But if I ask what's the dog's velocity, I am not asking that accidentally. I am now asking you to tell me the direction and the speed. So without it, the direction is probably worth a point. So if you just write 136 meters per second, I'm likely to say, sorry, you're going to lose a point. And be careful there. If you pointed downwards as positive, then 136 meters per second technically is correct. Do you understand why I'm saying that? Because you don't usually put the positive sign, in there. So I will be looking at the context of your answer to see, did you list upwards or downwards as positive? Not that I have so much time to grade these, but I will look for that kind of stuff. Oh, and our time together